Hi everyone, in this video we are going to solve one more problem. The problem name is maximum depth of a binary tree and the problem number is 104. So first of all we are going to discuss about this problem, what this problem want to say. After that we are going to see the logic part, how we can solve this particular problem, and after that we are going to implement our logic in C++, Java and Python programming language. As solution is going to be very easy, just two line of code, right? Alright, so first of all, let's see what this problem says. Given the root of a binary tree, return its maximum depth. So we need to just return the maximum depth of a binary tree and we are given with the root only, right? Okay, a binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So guys, let's take this example, then try to understand this problem. So we are given this tree 3, 9, 20, 50 and 7, right? Now guys, we have to return the maximum depth from root node, right? So you can see the one path from 3, we are having this one, isn't it? So the maximum depth here is nothing but 2. So we can say maximum depth is nothing but 2 because we are having two node in this part, right? All right. But if we take this particular path, then you can see we have maximum depth nothing but 3. So because we are having a 3 node in this particular path, right? And if we take the maximum depth of this one, then you can see we are again having a maximum depth 3, right? So we are taking that particular path from root node where we are having a leaf node, right? It is not like that we are taking this particular path. We have to take that particular path from root node where we can get a leaf node, right? So the first node should be root node and the last node should be a leaf node. All right, so here maximum depth is nothing but 3, right? But if there may be a one more node here, then you can say the maximum depth is nothing but it's going to be 4. I hope this much makes sense, right? So maximum depth we have to find out from the root node and we have to return that particular thing only. So it is an easy problem, not a hard work, right? So let's discuss about what is the logic to solve this particular problem. So here I'm going to just write here nothing but a logic. And first of all, you tell me if you just I would say just think about in tree only in tree concept. What logic you can use? What is the logic coming in your mind that you can solve this particular problem? So guys, if you know tree at intermediate level or a basic level, then you must have heard about this thing preorder traversal, right? We use this for traversing our tree, right? So we are going to use a preorder traversal to solve this particular problem. All right, now how we can use it? And so let's see. First of all, I'm going to make same tree and we're going to understand this logic by just dry run on this particular test case, right? This example. So I'm going to make just one null node because if a 9 is a leaf node, then their child is not going to be any child. So we are going to say null null. Here also null null and null and null, right? All right, now guys, we are going to say from root node, just for getting a maximum depth for this node 3, we need to ask the maximum depth from the third child node and add 1 into it. So this is nothing but left node and we can say this is nothing but right node, right? Why it is so? Because this 3 is going to be definitely in our path, right? We know that if we are standing on any particular node and we want to find the maximum depth, then we can say that node should be coming that particular path, right? So 3 is going to be coming that particular path. So we are adding 1 already. All right. Now we are going to say just add the maximum node, maximum depth from left and right side. Because we can't take two paths at the same time. That makes sense, right? We can't go in their direction, in that direction as well. We can go only in one direction, right? So if we can't go in the two directions, so we can go either in this direction or in this direction. So I'm saying that we will move to that particular direction, which will have the maximum depth. All right. So 3 is going to ask from the left node and the right node. Okay, but here also we are going to use a period traversal. So now we will move to the left side first. You can move to the right side also. It's not we can say different things because we are going to just take that particular path after getting both the side, right? So here first I move to the left side. So because I'm going to follow the period traversal. So okay, 9 is going to say fine. My maximum depth is going to be 1 plus my left side and my right side. So can't you see that this is nothing but a recursion, right? So here left side is also 0, right side is also 0 because this is null node. Let me add all the null node 0, right? So null 0 and 0. Max is nothing but 0 only, right? So left also 0 and max also 0. We don't need to add, we need to just find the maximum, right? So 0, 1 plus 0 is nothing but 1. So 9 will say the maximum depth till me is nothing but 1. Fine. And for 3, 9 is done, means left part is done. So we'll move to the right side. Now on right side we have 20, fine. So 20 will say, wait, my maximum depth will be nothing but 1 plus maximum of left side and right side, right? All right, so it's gonna ask from left side and right side. And 15 will say, wait, my same, it will go say 1 plus maximum left hand side. And 15 has nothing on, we can say on child, right? There is no child of 15, no left node, no right node. So it's gonna say 0. So 1 is gonna be the answer for 15. Maximum depth for 15 is 1. Similarly, the maximum depth for 7 is also going to be 1. Fine. And they're gonna return Now you can see that for 20, it's gonna say left side it also having 1, right? And right side it also have 1. So maximum is nothing but 1 only. So we can say 1 plus 1 is nothing but 2. So for 20, the maximum depth is nothing but 2. So and also you can see observe that here also we can see the maximum depth is nothing but 2, right? Now you can think that 3 gonna ask from left and right, and you can see we have traverse left side also, right side also. We are gonna return 1 we are getting from left side, 2 we are getting it from right side. So maximum is nothing but guys 1 comma 2 which is 2. So we can say 1 plus 2, right? And this is nothing but 3. So you can see that we are going to return answer nothing but 3, and in the output also you can see we are having answer 3. We are not doing anything, we are just saying that 1 plus left side maximum or right side, right? This is the thing which we are going to use, but only for the node where our node exists. If node is not exist, then directly we are saying that this is nothing but 0. I hope now this makes sense. We are saying that 1 plus maximum of left side, right side, if the node exists. If node does not exist, then it is 0. So don't you think that this is in just 2 line of code? So let's see in 3 programming language, C++, Java and Python, how we can solve this. And just we need to write just 2 line only. So let's move to the implementation part. Alright guys, so here let me see the max size 125. Alright. Now guys, the first of all the Python solution, what we are going to do, we are going to say if root exists, then fine. If no root exists, not root, that means root does not exist, then we are going to return 0 because this is null node, right? But if it's not the case, then we are going to return the maximum. Let me write return, and here we are going to say 1 plus maximum of self dot max step, and here I'm going to say root dot left, and again self dot max depth, and here I'm going to say root dot right. I hope this makes sense. We are moving to the left side and right side. We are going to take maximum part and adding 1 to it. Alright. So now let's try to run this code and see whether it's working fine or not. I hope it should work. And here you can see that both the test cases are passed. So let's try to submit this code. And you can see that it's successfully accepted, right? Now let's move to the Java programming language and solve this particular problem in Java. And here guys, we need to do the same thing. We can say if, let me write if root is equal to, we can say what we do null. If root is equal to null, then we are going to return nothing but 0, right? That makes sense. But if it is not the case, then we are going to say return 1 plus, we can say maximum math dot max, max dot max, and here we are going to say max depth, and we are going to call this particular for root dot left, and again for root dot right. So max depth root dot right, and here let me write a semicolon. Alright, so let's try to run this code and see whether we are getting any error or not. And you can see that both the test cases are passed. So let's try to submit this code as well. And you can see that the answer is solution is nothing but just of 2 lines, right? So that's the reason I'm doing in 3 different programming languages now. Alright, so now let's move to the C++ programming language. And here also what we need to do only, I guess I have already solved this particular problem in C++. You can see that if root is equal to null pointer, then we are going to return 0 only. And return 1 plus maximum depth of root dot left and maximum depth of root dot right, right? So I have already solved in the past. So let's try to run this code, and I'm not going to submit this code because it has already been submitted, right? You can see that both the test cases are passed, and it will definitely gonna submit as well, right? So this was the problem we have solved in 3 different programming languages. We have seen that logic part as well, how we can solve this particular problem. And if you learn something new in this video, don't forget to hit the like button, subscribe my channel, meet you in the next video.